Hello, this is Bent Frame by Sprechta. It is a puzzle with a lot of arrows, in particular singular arrows and double arrows as well. So let's look at the rules of this puzzle. So normal Sudoku rules apply. The digits 1 to 9 appear in every row, every column, and every 3x3 box. Digits along arrows must sum to the digit in the attached circle. So what they're saying is these three digits sum to this digit. So you could have like a 1, 3, 1, 2, 4, and then this would have to be 7 because 1, 2, and 4 add up to 7. The additional possible it is not stated specifically in the rules, but it is possible for digits to repeat. So you could have something like this, making this a 5. This is okay for an arrow. Digits along lines with 2 circles at the ends must sum to the sum of digits in those circles. So that is saying that the digits on an arrow sum to the same as the digits in the circles. So these are called double arrows because they're basically arrows pointing along the same line. And digits may not repeat on the same double arrow circles, so you couldn't have something like this. That is not valid. And those are the rules. So with that, let us start solving. Now the first thing I see is this arrow over here, because these three digits are on the same row, so they cannot repeat. Even if you are allowed to repeat on arrows, they still must obey Sudoku rules. And actually, minimally, this cannot be a 1, therefore must be 2, 3, 4 at minimum, meaning that this is at least a 9, and so it therefore must be a 9 because there's nothing greater than that. So this is 2, 3, 4, making a 9. The remaining cells are these cells here. This is actually sort of similar, in which we can say that this is at least 1, 2, and 3. So this is at least 1 plus 2 plus 3, which is 6. So we can do that. Okay, the next thing I wanted to see is actually these big arrows over here, because all of the digits on the line are actually different. They are in the same box. So minimally, what can you put here? You can put 1, 2, 3, 4, and 5 on this. You can put 1, 2, 3, 4, and 5 at least on the line. And that would actually make up 15 at least. So these two digits sum to at least 15, which means that they could be 6, 9, 7, 8, or they could be anything that's a bit greater. But because digits cannot repeat, then they are maximally 8 and 9, which are 17. So digits here are at most 17. What does this say about this over here? Well, because this is 2, 3, and 4, this cannot merely be the digits 1, 2, 3, 4, and 5. In fact, they cannot have all 1 through 2. They cannot have all 2, 3, and 4 on them. So at the very minimum, you can have only 1, 2, 3, 5, and 6 if you eliminate the highest digit from this set of lines. You can't have 2, 3, and 4. So if you remove the highest digit, which is a 4, you'd have the smallest possible value. So this is at least a 1, 2, 3, 5, and 6. Which add up to 1, 2, 3, 5, 6 is 11 plus 6 is 17. So that means that these two cells add up to at least 17, which is good because they cannot add up to more than 17, otherwise you'd be forced to use 2 9s, which is against the rules. Digits may not repeat in the same double arrow circles. So this is in fact exactly 18 and therefore must be an 8-9 pair, meaning that our initial saying that this is minimum is right, and therefore must be 2, 3, 5, and 6. This is therefore not 2 and 3 and must be a 4, giving us our second digit. These digits are therefore 7 and 8 to finish the box. So that's decent. That's a decent amount of progress. Can we do the same thing here though? I don't think it's the same thing here, because this could still be a minimum of 15. And then these could be 7, 8 or 6, 9. And it could be 7, 9, 8, 9 as well. So we can't really say much about that. I want to take a look at these arrows specifically, although they're not as restricted because digits can repeat along the arrow. The rules do not say anything about that. So this something like this is fine. It's obviously not. Obviously, it's not clearly just 2 1s, but you could put 2 1s here if you wanted to. Now, could this be a 1? I don't think this can be a 1. And the reason is, if this was a 1, then this would have to be 2, 3, 4, 5, and 6. And in fact, actually, can we say that this definitely must have some specific value on it? And I think the answer is yes, it must have 1, 2s, and 3s on it. That is because without a 1, you'd have 2, 3, and 4. Without a 1, your digits here are minimally 2, 3, 4, 5, 6, which add up to 22. And you can't have 2 cells add up to 22, that's just not possible. Same, you can't be missing a 2 here, because then your digits are 1, 3, 4, 5, 6 at minimum, which add up to 19. So again, not possible. And you can't have 3 here, because if you had 3 here, if you're missing a 3, basically, you minimally have 1, 2, 4, 5, and 6, which add up to 18. Yes. And you can't put 18 in here because you can't have double 9s according to the rules of the puzzle. So therefore, these 5 cells, and by the same logic, these 5 cells must have 1, 2, and 3 on them. And therefore, this 1 sees those cells which cannot have a 1 in there. The 1 is in one of these cells, which will always see these cells. So those cannot have 1 in them. Okay, so that's probably useful. Probably. I mean, this is actually exactly the same, isn't it? Yes, it's even though the circles are in different positions, you still have 5 different cells here, which sum to 2 different cells there. So those are also containing 1, 2, and 3, and because 1 is in one of those cells, those cannot be 1. So 1 is one of those cells, which I guess by effect puts a 1 in one of these 3 cells. And actually, minimally, because these kind of 2 and 3, these are 1, 4, and 5, which add up to 10. So it doesn't really help much. Okay. I guess what this means is we can say something about this cell here, which, you know, kind of a 1, 2, or 3 on them, so it's minimally a 4, but maximally can only be a 6, because if you had 7 on there, then these cells are at least a 3, because they're at least 1, 2, which means this cell will be at least a 10. So this can't have 7 or higher, and therefore can only be from the digits 4 to 6. These digits don't have the similar restraint though. So this 2, 3 pair sees that, so that can be 2 or 3. I guess that's a little something we can see. Not really sure what else we have. Not really sure what else we should be looking for either. What is 1, 2, 3, 5, and 6? Is this right? 1, 2, 3, 5, 6. Which is 8 and 9. I'm not sure we can do a little bit more math maybe. If this was a 6, it would have to be a 1 and 2 to make this a 9. Oh, but therefore, because this is a 4, this is at least 1, 2, making this at least a 7. So this can be 6, I guess. Which is... well, I don't guess, but... I know this can be 6. But I suppose it doesn't really help much either. Maybe these will help, because these are at least 4, right? Yeah, so these are at least 4, these are at least 1 and 2, which means that this is also at least a 7. Ah, and because it cannot have a 9 here, it's just 7 or 8. I think this is similar because this is at least a 4, and these are at least 3, so this is at least 7, so it's either 7 or 8. This actually forms a 7-8 pair in this column. Although digits can repeat, like these two digits can be the same. Although they probably aren't, right? Yeah, because if they were the same, they can't be 1, 2, and 3. They can't be 2 4s because of this 4. And they can't be 2 5s because that will add up to at least 10. So these digits are not the same. And because these two digits are not the same and these two digits are not the same, these are actually 3 distinct digits. And now how does that help? Well, if they were 3 distinct digits, then they must include a 1 somewhere. And because this cell can't be 1, one of these cells must be a 1. And the reason is they include 3 distinct digits, but it can't be 2, 3, but and if they did not include a 1, it would be 2, 3, 4 at least, making this at least a 9, which doesn't work. So it must have a 1 somewhere, which is not there. So 1 is in one of those cells. And then, well, if it was a 7, it's 1, 2, 4, which we know puts a 4 there. But if it was an 8, it could be... Yes, if it was an 8. If it was an 8, this still cannot be a 6. Because 6 plus 1 plus 2 is at least a 9 already. So no matter what you have here, this is always at least a 4, but cannot be 6 or greater, so it's therefore 4 or 5. And these cells, I guess, are therefore 1, 2, or 3. Because if you had a 4 in like any of these cells, then this is minimum a 9 already. 4, 4, and 1. So you can't have 4 in these cells and therefore must have at most a 3. So those are 1, 2, or 3. In some order. Okay, that's somewhat helpful. Can we do the same here then? This is at least a 4. And this is at least 1, 2. But could there be repeats? I think these two could repeat if they wanted to. Because those could both be 4s. Well, no, they can't both be 4s because, yes, they can't be 1, 2, or 3. They can't both be 4s because that would make this at least a 9. 4, 4, and 1 at least. So they can't both be 4s, they can't both be 5s or higher either. So in fact, they cannot be duplicates either. So these cells are once again 3 distinct digits, which therefore must include a 1, and therefore must have a 1 in one of these cells. Is that helpful? Well, I think by the same logic as this is at most a 5, because you kind of have a 6 on it. So maybe it is. But I wouldn't guess so. Now, because we know this is 1, 2, or 2, 3, what does that say about these cells? Yeah, if it had like a 2 in it, what does that mean? Well, there must be a 2 in one of these cells then, because if there were no 2s in these cells, you'd put 2s in these cells, and those cells are giving you 2 2s in the entire column. I'm not exactly sure if that's useful though. It doesn't feel like it. I really want to say that maybe these two cells are affected by this cell and by these cells. But these could still be an 8-9, couldn't they? They could still be 8-9. And then this could be a 7 if this was a 4, because we know 8, 9 doesn't have a 4 in it. Maybe that's it then. Maybe there's a 9 in one of these cells. Because if there was no 9, then this is at least 15, meaning these are definitely just 7 and 8. But then that affects this, right? Yes. Yeah, okay, yes. That is very interesting because this is 4 and 5. So this set cannot have both 4 and 5 in it. And therefore has to be at least a 1, 2, 3, 4, 6, which is already a 16. And so what that means is that this cannot be 7 and 8. In fact, yeah, therefore it cannot have no 9 on it. If it had no 9 on it, it would then at most be 7 and 8, which adds up to 15. But this has to add up to at least 16. So this must have a 9 on it somewhere. And by the same logic, because of this 4, 5 here, this must have a 9 somewhere. Which forms some sort of X-wing looking mess over here. Same here as well. And since there's this sort of X-wing thing over here, I guess you could say none of these are 9s. And none of these are 9s. But that does feel like I'm getting ahead of myself. Because it could still be 7, 9 or 8, 9, and we don't actually know which one. Although maybe we could use this 4, 5 to look at that, because... Well, because what? This could also have a 9 on it, right? And because of that. Well, can it have a 9 on it? Can it have a 9 on it? I think it can. If it had a 9 on it, there wouldn't be this same X-wing anymore. But by this box, I'm pretty sure you cannot have 9s on both of these cells. Therefore, one of these cells would have to have a 9 as well. So, honestly, this might be where I start, right? Because is it possible for me to prove that there is no 9 on this? What if there was? If there was a 9 in one of these cells, how would that affect the rest of the grid? Well, you sort of have to have some alternating pattern over here, where it's either 9 in those cells or 9 in those cells. Right. So if there was a 9 in there, your two possible configurations of 9s would be there, which would always force a 9 in the middle, no matter what you do. But that's on the condition that 9 is in one of these cells, which may not even be true. It could be 7 and 8. And that is what I'm trying to get at. Like, if I know this was 7 and 8, that would make this a lot easier on me. But I just can't really prove that this is 7 or 8. I don't think so. Yeah, these work together very well, in fact, if you have 9s on them. Except maybe purple doesn't work. No, purple might work. Because if purple works, then this is either 7 or 8, which forms some pair with this. But that will make that a 9, which is fine. And if orange was 9, that affects this one, which cannot be a 9 anymore. That forms a 7 or 8, which forms a 7 or 8 here, which, you know, sees that and that. But I don't think that's how it's meant to work. Okay, wait a minute, wait a minute. Is it this? Is it this one? We figured out that this is at least a 10. These are both very high digits. We know this is either 7, 8, or 9. And in fact, I can probably do that here. These are all either 7, 8, or 9. If they were 6, even with the 9, that would be 15, which we know is not possible because this must be at least 16. So these are both very high digits. What about these? How high could they be? Well, this is a sort of an X-wing, right? So there cannot be 9s in here. There can't actually be 7s and 8s in here either, because that would force 9 into both of these cells. So I mean, this is 6 and... This is at most 6 and 8. That's still a lot though. 6 and 8. Although maybe... I mean... No, it doesn't work like that. Yeah, so we have a lot of degrees of freedom on this one. I guess you could say that because of this 4, 5, then this can't be 1, 4, 5, and therefore it's at least 1, 4, 6, which is 11, at least. But these could sum from 11 to 14 very easily. So unfortunately, that is not where we go. I noticed there's a 7, 8, 9 triple here. So where does 6 go, I guess? Well, 6 could always go on the line. There is no restriction on that. Because this could be 1, 2, 3, 4, 6, and that's fine. Oh, in fact, this cell might be restricted. Because this is at least 15. Ah, this is at least 15. So this cell is at most a 6, right? Wait. Sorry. No. This is a 5 or 6, I think. Because it can't be 1, 2, 3, or 4. If you try to put a 7 in here, then this is at least 1, 2, 3, 4, 7. That is 17, which is possible with 8 and 9. Oh. Because then you could have like a you could have like a 7 here, you could have an 8 here, you could have a 9 here and an 8 here. And then that looks like it works. So this could be a 7, but I don't think this can be an 8. If it was an 8, then these would have to add up to at least 18, which doesn't work. So this is anywhere from 5 to 7. No, I was supposed to stop myself. Actually, I don't think this can be a 5. Right, because I think maybe we might have to think about all 6 of these cells, or even the both of these sets of arrows together. Maybe. I'll eliminate these cells first, because what are these? Like, what is the range of these values? Is what I'm saying. It's like, is this well, at the very minimum, these cells contain the digits 1 to 6, which sum to 21. I guess then we can say something about this, because this is at least a 3. So this is 21 plus 3. 21 plus 3 is 24. And so these cells sum to a minimum of 24. And then these cells, well, these can't be the same as that, and this can't be the same as that. The only issue is that these two could be the same digit. These could be the same digit. And if they were the same digit, then this no longer has to be as large as 24. Right? Because if you duplicate the 7 here, and then you make this a 9, so 7, 7, 9, that sums up to 23. Wait, what am I saying? This is at least 21. And this is at most 24. So our degrees of freedom range from 21 to 24. Oh no. Oh no. I don't think that's it. This might be a bit suspicious though. In fact, this can actually be higher than 24 if you make these like 889, which add up to like 25. So unfortunately, eight, 9, and then this is 9, this is 8. Yeah, so unfortunately, actually, this is probably a really bad idea to think about. Wow, so where do we go then? It's like, could this digit be as low as a 5? Because if this digit was a 5, then these digits over here have to be at least 1, 2, 3, 4, 6, 7, which is 23. Well, that's fine, right? Well, 23 plus these two means is at least 26. But we know this is a maximum of 25 as we've seen just now, because these can't both be 9, but they could both be 8. And in fact, you could have 8, 8, and 9 is what this could be at maximum. You kind of, you can't have these both be 9, but these could both be 8. You could also have, yes. So this is at most 25. But if this was a 5, then these cells are at least 26. This doesn't work. This is at least a 6. I can't do the same thing here, can I? No, that could still be 5, 6, 7, or 8. Okay, well, we're working through this very, very slowly. It must be some sort of geometry that I'm not seeing with all these cells specifically. We're gonna color them again and see if I can say anything about them. This one being off-center, or this one being different from the rest, feels very suspicious to me, because it did help me figure out that this is a maximum of 25. But like these don't have that same restriction. Although I could say that this is still at most of 25 as well, because you could have 9, 8, and 8 here at maximum. So this is at most 25. But then again, this is oh, this is 24. Oh, this is not 21, it's 24. Yeah, because this is at least 21, and this is at least 3. So this is at least 24, and this is at most 25. Which means that in reality, this is actually, these are actually bounded. Wait, okay. So let's look at this again. I made a mistake in saying that this is at least 21. This is not. It is at least 24. And this is at most 25. So in fact, our degrees of freedom are very restricted between 24 and 25. So that might eliminate 7 from this set here. Because, well, if this is at most 25, a 7 here would make this At least a 22. Oh, that works. Ah, this works. So this could be a 7. But we know this is between 24 and 25. We would say the same thing about this actually. These cells are a maximum of 25 because this is 8 at most and these are 8, 9 at most, which give us a maximum of 25. Whereas these cells are a minimum of 24 because it's 21 plus 3. So, oh man. I mean, isn't it the exact same here as well? Because this is at least 21, this is at least 3, right? And then these are again at most 25. So these are all actually equally constrained. And this is really weird. Because this is 989. Although this is not actually that restricted, because this actually follows the same as this, I'm pretty sure. This could be a 9, which gives us a lot more options on this specific set. Because this is no longer a maximum of 27, no longer a maximum of 25, it is now a maximum of 26. 26, yeah. Because you have 9 and an 8, 9, which add to 26. So this set here is a little bit less restricted. What if it was 24? How could you make 24? Could you duplicate 7s at all? No, because 7 plus 7 plus 9 is only 23. So, if you had 24, it must be 7, 8, 9. If you had 25, it must be 8, 8, 9. Right. So what does that mean? It has to be 8, 9, and then a 7 or an 8. Which is why I said there must be a 9 in one of these cells. Because that 9 cannot be here. Otherwise these are 7, 8. And we already knew that's incorrect. Oh, then I guess in this cell, where does 9 go? 9 can't go in any of these cells. Right? Yeah. Because the remaining cells would sum to at least 10. And then 9 plus 10 is already 19. So 9, yeah, so 9 in this, so 9 here has to be there because we know this is not 9. So that's just 9. That is just the digit 9. So what about 9 in this box? Yeah, again we know 9 cannot appear on the 5 set. 9 is no longer in those cells. So 9 is one of those cells, which means that 9 is not there. And therefore, in this set over here, 9 can only be here. Which helps, because that's 8. That's an 8. That's a 9. This is no longer a 9, making that's a 9. Oh, okay. Well, that was the digit we were supposed to be looking for. Okay. So 9 in this box is now in one of those cells. This is no longer a 9. But this must be 7 or 8 by the same logic as this. And in fact, because of this 7-8 pair, we know now that's a 9. Okay. Useful. So 9 is one of those cells. Can I say that this must be a 9? Or can this still be 7 and 8? No, because this is a 9. This could still be a 6 if this is 1, 2. So that means this could still be 7, 8 if I wanted it to be. And doesn't necessarily have to have 2 9s on it. Okay, but we have this now. Yes, and we know it's a 7, 8, 9. Yes, and that is a minimum because this is at least a 21. This is at least a 3. So this is at least 24, which is the maximum this can be. Or which is exactly what this is. So this sums to 24, which is a minimum, meaning this is exactly a 1-2 pair, and this is exactly the set of digits from 1 to 6. So this is no longer 7. These are, I guess these are 1, 2, 3, 4, and well, they're 1, 2, 3, 4, 5, 6 basically. These can't be 1. So 7 in this row must now be there. And then this, right, in this row, this can't be 6, 7, or 8, and therefore it must be 5 or 6. Which removes 6 from this cell. Actually, the 1, 2, 3, 5, 6 sextuple over here already does that for us. But these are now 1, 4, 5, and 6. 1, 4, 5, 6. Which forms a quadruple with this cell, so none of these cells are 4, 5, or 6. Which is a 2, 3 pair. So that helps. Yes, well, no, does it? Does it? I want to say it has some affinity with this set over here. Because these kind of both 2 and 3, meaning that this must have a 2 or 3 somewhere in there. Maybe. Let's try that. If this is a specific number, that number can't be here, so that number must appear in one of these cells. That number must therefore appear in one of these cells, which does not affect this. This could be the other color. And in fact, whatever other color this is, that would be one of these cells, which would then be one of these cells, which would actually join the 1, so that's quite interesting, whatever this digit is. But we know nothing of that right now. Does the 4, 5, 6 do anything here? I don't think so. Okay. Yes, but we can do the exact same thing here as well. Because we know now this is a 7, 8, 9 triple. This must be the minimum, 24, meaning this is also a 1, 2. So this is exactly a 1, 2 as well. And then this is exactly 1, 2, 3, 4, 5, 6. And then none of these are 1s. And then this forms a 2, 3, 4, 5, 6 quintuple here. So this is 7 or 8. Yeah. Alright, this is some really awkward pencil marking, but it helps, I think. It helps. Okay, so what does that mean? That's a 1, 2 pair over here in this row. I'm tempted to say where 7 and 8 go in the rest of the boxes. This is 7, 8, or 9, right? Because 1 to 6 are already all here. So this is 7, 8, 9. This forms a 7, 8, 9 triple here. Meaning that the rest of the digits are... well, this can't be 4. But the rest of digits are 1, 2, 3, 5, and 6. That does not help. Okay, what are these cells? I can say that... well, what can I say? Because this must have a 1 in it and a 4 in it. Oh, it must have a 4 in it. There you go. There can't be a 4 there, so there's a 4 here. Meaning that this must just be 5. Because it can't be 4. Therefore, with this 1, 2 pair, mix this an 8. That's a 7. That's a 7 as well. So this is no longer 5. That is 6. And in fact, 1, 2, 3, 4, 6 does in fact add up to 16, which we have marked here. So that is useful. None of these are 6 anymore. So that's 1, 2, 3, and 4. This is now a 5. And therefore, because this now can't be 5, it's just a 1, 4, 6. And 1, 4, 6 is 11. Which in 2 cells cannot be 2, 9. Cannot be 3... cannot be 4, 7. It could be 5, 6. It could also be 4, 7. Sorry, it could also be 3, 8, not 4, 7. So it's either 3, 8 or 5, 6. This 5 sees that, so that can't be 5, so that can't be 6. This 8 sees that, so that can't be 8, and therefore that can't be 3. Okay, so we have knocked these down to 2 options as well. These are 3, 4, 5, 6. And then these are not 4. That does not help. I mean, maybe that? Something to do with that? The 6 here might be an issue though. It in fact could be an issue. Oh, this 9 means that's no longer 9. Meaning that 9 has to be there in this box. Should have seen that a long time ago. Although to be fair, it doesn't really do anything either. Because we haven't said anything about this yet. In fact, I don't know, that might be where we need to next look. This can't have a 6 on it. It can't have a 7 on it. But it can't have a 5 on it because this is at least 15. So 5 or less here makes this 10 or more. So this can't be 6 or 7, so it must be 8 or 9. And then this... Well, 2 9s here means this could be 6, 7 or 8. Which maybe plays with this a bit. But we don't have an established triple there yet. So we can't do that. This is a 7, 8, 9, so these are from 1 to 6. Can I do anything with that? No, I don't think so. I mean, what are these cells actually? What are they at minimum? These can be both 1 and 2 because of that. So this is at least 1, 3. And then there's at least 1, 2, 3. Right. So that means that... That means that at minimum this is 4 plus 6. This is at least 10. Oh, that doesn't help at all because this is you know, this could be anything from 10 to 18. Whoa. Oh, oh wow, it highlights all the circles if you click this. Does this highlight everything that's not circle? No. But clicking on a circle highlights all the circles. Clicking on this one highlights everything that has 3 and 5 in it, I guess. Yeah. So nothing right now. Oh, and this box falls in one of those cells, which we've already established. And that's because... Yeah. So that means this is a 5, okay. And why is that? Why is that? Because this... Why can this just not be a 4? Right, because of the 2, 3, 4, 5, 6 quintuple here. So 4 is in one of those cells, which removes 4 from that cell, that's 5. With this 1, 2 here makes that an 8. So that's a 7, that is a 7 as well. That's an 8. So this in fact does not have a 5 in it, and is in fact just 1, 2, 3, 4, 6. This can't be 4, because 4 is in one of those cells. That is a little bit more help. We should start marking those down, to be fully honest. Those can't be 5. So 5's in one of those cells, which means those are... Yes, so 5 here removes 5 from that. And now, in fact, in this column, where can 5 go? 5 can't be in those cells, so 5 just goes there. That should be something that we've seen a long time ago. This is a 2, 3, 6 triple now. This is a 2, 3, 4, 6 quintuple. Sorry, quadruple. This 8 sees that, so that's 7, that's 8. Which... okay. Did we do anything with the 8s yet? Where does 8 go in here? 8 can't be on this line because 8 plus 1, 2, 3, 4 makes this at least a 19, which is impossible. These 8 see those cells, so 8 here must be there, which means that this is actually summing to 17. Okay. Well, 8 in this box are in one of those cells. And here, well, in this box, 8 is one of these cells. And we don't know which ones they are in. So 8 being one of those cells is, of course they are. Sevens maybe? Sevens could still be on the line though. This was 8, 9 exactly. So you could have 7, 1, 2, 3, 4. Oh, in fact, this 7 and this 7 see those cells. So 7 must be on the line. Yes, and that is a maximum because 7 with 1, 2, 3, 4 at minimum is 18. Sorry, it's 17, which can only be made with 8 and 9. This now can't be 9 and therefore must be 8. That must be 9. Ah, that's cool. So none of these are 7. So this now can't be 4. This is no longer 7 either. So 7 is one of these two cells. Which means this is 5 or 6. Along with this to make a 5, 6 pair. If this is a 5, this adds up to 4. And if this was a 6, this adds up to 3. So in both cases, they must have a 1. It's either 1, 2 or 1, 3. In this box, 1 is one of those cells, so 1 is in none of those cells. Therefore, in this box, 1 has to go there. That's cool. This is almost something. This, we know... What do we know? We don't know much. Oh, in fact, yeah, where can 7 go in this box? 7 must be there. So this is... well, this could be anything, right? No, 5. 5 in this row has to be there. So that's 5. So this is 1, 2, 3, 4, 6 quintuple, which I didn't see. I thought it was like a lot more complicated than it was. But no, 5 is here. So that's good. Eight in this box now. 8, yeah, 8 can't be here, so 8 goes there. Meaning that this is 6, and therefore, because these two must sum to 11, this must be 5. This is no longer 5 or 6, so it's 3. Therefore, 5 in this box has to be here. This is no longer 3, and it's a 4, 6. This 6 is that, so that's 4, that is 6. This is therefore 1 or 2. 8 in this box. This 8 sees those cells. These 8 see those cells, so 8 goes there, forcing a 9 up there. 5? Yeah, this 5 sees that, so that's 6. That's 5, meaning this is actually just 1, 3 to make a 4. So these can't be 3s. This is either 2, 4, or 6 to complete the row. I mean, these are also 2, 3, 4. Well, this 6 sees that, so that doesn't work. Sorry. Which means 7 is somewhere on here. In fact, yeah, 6 in this box. 6 sees all those cells, so 6 must be there. So these are what? These are 2 4 7. Yeah, to complete the box, which sees this cell. It can't be 2 or 4. It must be 3. 3. So those are no longer 3. So what are these adding up to? They are 6% is 13. These add up to 19. So these add up to, sorry, not 19. These add up to 17. So with this adding up to 13, these must add up to 4. I can only be down with 1 3 because they can't repeat. Yeah, so that's no longer a 1. That's a 2. That's a 1. This can't be 1. This can't be 2. This can't be 2 either. And in fact, this 6 here makes this a 1. That's a 3. That's a 2. That's a 6. This means that's a 2. That's a 4. That is a 6. These are no longer 2, so 2 goes there. That is no longer 2, so that's 3. Those are no longer 3. That is no longer 2, so that's 4. That's another 1 2 pair. This 1 sees that. So that's 2. That's 1. That's 2. That's 1. That is 2 now to complete the row. And these cells are 4 and 7. These cells are 3 and 5. This 3 sees that, so that's 5, that's 3. These are 6 and 4. This 6 sees that. 4 here, 6 there. This 4 sees that, so that's 3, that's 4. Okay, I think this is just regular Sudoku from now. It probably is. This 6 sees that. And this 6 sees that, so that's 6. This is, it's gonna be 7. Wait, what? It's 1 2 3. Hold on. Wait, what am I not seeing? This is 2 4 7. This is 1 3. This is 1 3. This is 4 7. This is 1 4. This is 2 3. This is not a deadlock pattern. No way. There's just something I am not seeing. This 2 4 7 looks very sus. But this is a valid quintuple, isn't it? 2 3. Yeah, 1 2 3 4 7. And then this is also valid. 1 2 3 4 7. But there's no way to fix that. Unless I did some math wrong at some point. This invalid. This should not exist. Maybe it's not actually a deadly pattern, I just am not seeing something. Oh yes, this 1 3 pair over here sees that, so that's 4. That's 1. Alright, that's 3, that's 1, that's 3. This 3 sees that, so that's 2, that's 3. This 2, this 3 sees that, so that's 1. This 2 sees that. Oh, we should have seen that along. This 2 always saw that, didn't it? That's a 4. This 4 sees that, so that's 7. That is 4. This is now 7, and therefore that's 2. Solving the puzzle. Oh, it doesn't include solution. Well, everything is right, hopefully. Cool. Look at that. In under an hour even. But this was really fun though. I really enjoyed like trying to work this out. The minimum and maximum here were actually pretty it was actually pretty challenging to spot, but it was very satisfying. So thanks for the puzzle. I hope you enjoyed watching me solve that as well. I will see you now. Bye bye.